Okay, for this question, I think the first part is quite easy. They gave you a table, and they just asked you to draw the graph, and they give you the vertical axis and the horizontal axis, and they have given you the scale, so it's actually very easy. So what you need to do will be you come up with a new table. So you just make sure you calculate your new table. And then you go according to the scale that they provide you. It's not going to be difficult. Okay, so it shouldn't be an issue. Okay, so the second part, your job is to use the graph to estimate. So some students will be asking me, so how do I use the graph? So if you would like to use the graph to estimate the value, you will need to linearize the equation. So that means you got to flatten the equation. So the equation that they gave you got to flatten into the axis. So you will need to flatten into the axis so that later on I can make use of the intercept and the gradient. The feature of a straight line will be there is a y-intercept, there is a gradient. So I need to flatten the equation to get the axis first. So how I flatten? In a way, it can be called flatten or it can call linearize. Okay. So I bring the number over. After I bring the number over, I introduce ln on both sides. After I introduce ln on both sides, this is where your logarithm rule comes in. So if it's a log of a product, it will become a log A plus log B. So that's how I split into two log. After I split into two log, this can be a power that I can bring down. So in a logarithm, they are allowed to bring down the power. So I bring the power down, and don't forget ln E is a value of 1. So after a while, you will realize that this is your capital X and this will be your capital Y. And your 1 over K is the gradient. And your ln A is your y-intercept. That means your y-intercept will help you to find the value of A. So if you go back to your graph, the y-intercept that I have here is around 2.5. So from the graph, the feature of y-intercept is 2.5. So that means, right, my log A is 2.5. And from there, I get rid of the log and get the value of A. So I get my value of A in 3SF. So the feature that I use will be the y-intercept. So if I will need to find K, I will need to use gradient. So how am I supposed to get gradient? I will get any 2 points. Okay, so you get any 2 points. So usually I like to use the intercept point and any nice looking point. So I use 2 points that I can get from the straight line and I calculate my gradient. That gradient will be 1 over K. And then that's how I find my two values. So if you linearize and you know how to use the gradient feature and the intercept feature, then you can find two unknown. Okay, then from there, let's take a look. So the question says that state the speed of the vehicle at O. At O, that is where the timing is 0. So the timing is 0. You can use back the original equation because it's just 1 mark. So you put t equal to 0 into the equation and you can get the starting speed. That means the vehicle already starts at that speed when t is equal to 0. Okay, it's the explanation part that some students can get stuck. They just need you to explain. They didn't actually want you to go and work it out. So if you will need to use your graph to find the value of t when speed is 5, your v equal to 5 has to be converted to the axis that you have. So I need to convert v equal to 5 into the axis. And that will have given me a 2.08, which is a capital letter Y. So capital letter Y equal to 2.08. So essentially it'll be something like this here. So that is a 2.08. And if you read down, this will be the timing. So you can just mention that you add a horizontal line and the intersection will give you the time, or you can just read and give it to them. Okay, subsequently, this one, they will ask you to use your values of A and K to find the time where the velocity the vehicle comes to rest. So what you do will be, you return the two values that you have found. So return it to the original equation. So that's what I did. I returned to the original equation. Then I will equate the whole expression equal to 0. It looks like very troublesome because there's a lot of decimal, but it's actually not so bad. So you can just use your A and K, put it back into the original equation. Then you substitute your B equal to 0. You substitute your B equal to 0 and eventually you find the time. So this same part, right, they can ask you, they can ask you to get it from the graph instead. So if I'm going to get this from the graph, again, I got to convert it to the vertical axis. So if I convert to the vertical axis, I will get a ln 3. So if I'm trying to get it from the graph right now. So if I got a ln 3 is 1.09. Okay, to make things simple, I just put 1.1. So I will need to look at 1.1. Okay, by right, I can do it this way, but my graph is not sufficient. So I wasn't given the sufficient thing to do. So if the graph is sufficient, I can actually read it off here. Okay, so if let's say the graph is sufficient, then you might be asked to find it from the graph. So you got to translate it to the axis first. Very similar to part 4. So everything you use will be based on the axis in the question. It's not like the EMATH graph where you just simply read off the X and Y. No. Okay, and the linearization is important. If you don't linearize, you cannot be using gradient to find unknown. You cannot be using y-intercept to find unknown. So that's actually the key feature of linear law.